was 405 years ago that Galileo Galilei discovered the moons of Jupiter and revolutionized our understanding of science at the time. No longer were we, the Earth, the center of the universe. Europa might have a similar prospect. Europa is among this family of Galilean moons, Io, Europa, Ganymede, and Callisto. It's a challenge to explore Europa because it's immersed in Jupiter's giant radiation belts. Jupiter's magnetic field is enormous, acts to accelerate particles in the Jupiter system, and therefore makes it a challenge to explore Europa. When you look at Europa, it doesn't look like our moon or most other natural satellites. It's not covered with craters. And from the sparsity of craters, we can say that the surface age of Europa is about 60 million years. So something has repaved Europa's surface in the time since dinosaurs roamed the Earth. This is what we think the interior of Europa is like. A thin skin, about 100 kilometers or so thick, of H2O. It was a magnetometer that told us there's probably an induced magnetic field at Europa. And what could be causing that induced field but a salty liquid water ocean relatively close to its surface. As Europa and Io and Enceladus go around their parent planets, it's in an eccentric orbit. So as they get closer to the parent planet, they're stretched out, and farther away they contract a bit. And Europa is orbiting in 3.5 Earth days. Every 85 hours, its surface is going up and down by about 30 meters. So that flexing is causing heating, frictional heating inside the moon, which can maintain an ocean. It can also cause cracking of the surface. It's a bizarre array of ridges and bands and cracks that we think are related to this flexing and kneading of Europa's surface. That ocean, we believe, is in direct contact with the rocky mantle below, making it pretty unique among icy satellites. One thing we're really trying to get at in understanding the potential habitability of this probable ocean, first we want to confirm the ocean, we want to understand, is there communication between the surface and the interior? Because on the surface, we know there are lots of oxidants made by the irradiation of Europa's surface. And if those oxidants can get into the ocean, that would be a fantastic fuel for life. Europa also shows these dark pits and spots, which we think are related to convection of its ice shell. Europa shows some regions where it looks like the surface has been disrupted. This kind of looks like an Arctic ice flow. The surface has been broken up, disrupted. Large blocks had tilted and rotated in this kind of hummocky matrix. And we think there was almost certainly some component of liquid water to allow these blocks to move about. There might be lakes below Europa's surface in the ice shell, in the shallow ice shell today. So NASA gave the green light to a Europa mission just this past summer. And we've been looking at what we've been calling the Europa Clipper concept, NASA to pick the real name in the coming years, a solar-powered mission that would make many, many flybys of Europa, equipped with the types of spectrometers, imagers, etc., to characterize Europa's potential habitability.